Obviously, we know that there's a sand shell and a sandy silt core. Here we're able to assume that the semi-impervious foundation could be well-graded sand, the impervious foundation low plasticity clay, the toe is poorly graded gravel, and bedrock is given as shale. Now with these geologies, we're able to draw engineering parameters for hydraulic conductivity. So I referenced the chart by Rawls, Brockensyke, and Saxon from 1982, which provide me proposed hydraulic conductivity values which I can use to calibrate my model. Next, looking at the boundary conditions. The boundary conditions for the inlet head are sourced directly from the Excel file that we have for the upstream reservoir level data. The outlet head is based on a simple proportional model, which you can see on your right, which is given from the inlet head and proportional model, knowing that the outlet head ranges and fluctuates from 1611 feet to 1616 feet. Piezometer A and piezometer B are used as boundary conditions after calibrating the model. So once I calibrate, those are used to then validate my model. And I use GeoStudio CW software because of my prior experience with software. So very similar to rock science, I drew my problem geometry based on the figure, and it's more challenging than it looked because the scale X and Y were a little different. I defined my materials based on what I said, the hydraulic conductivity values. I input my boundary conditions as stated in the previous slide, and then I ran in several iterations until I was able to validate my model with the piezometer A and piezometer B values. So in validating my model, some of my hydraulic conductivity values changed. So you can see in this chart my proposed hydraulic conductivity values from Rawls et al. In 1982 to my calibrated and validated hydraulic conductivity values. Some more information about the model is I use steady state seepage analysis and a 65-foot mesh, which is acceptable and practical given that we have a 5,000-foot cross-section of the dam. Here are my results and my output for day 753 and day 1846 in the GeoStudio software. Looking more closely at these results for day 753, you can see my total head values for each point with boundary conditions and all 5 piezometers, the 3 that I'm predicting as well as the 2 that we have. And also looking at day 1846, I'll go a little deeper in this one. So similar to the results of day 753, piezometer 1 was the most interesting because there we encounter artesian water pressure, which I would have expected prior to that, given that it's in a confined aquifer below the impervious clay foundation material, bounded by a sheet pile heat into shale bedrock, and right above the shale bedrock. Another trend to notice is that the values for my total head are consistent with the hydraulic gradient of going from the inlet head pressure to outlet head pressure. So final conclusions, there's my chart for my GeoPrediction. The first 2 bullets I covered in the previous slide, and then another trend that I noticed was that my day 1846 predictions were all greater than my day 753 predictions. This is consistent because I don't expect that because the boundary head condition for the inlet was greater than in day 1846 and day 753. Here are my references, and a quick acknowledgement to the ASCE Geo Institute and NGIT Albert Drummond Honors College for funding my trip to my 2nd Geo Congress, Dr. Matthew Sleep and the volunteer judges for their time, and my advisor, distinguished Professor Jay Nagoda at NGIT. Thank you, and any questions?